So in this video we're going to look at how you would calculate kinetic energy of an ion in a mass spectrometer. So we've already considered how we will calculate the mass of an ion, and if you've forgotten about that, go back and watch the video again. We must have that mass in kilograms, so we must find that number in kilograms for one ion. And remember that kinetic energy is a half mv squared, where m is mass in kilograms and v is velocity in meters per second. So how would we calculate the kinetic energy? So remember that we worked out on the last video how to calculate the mass. So we took the isotopic mass and turned it into kilograms and divided by Avogadro's constant to get the mass of the ion, which was 6.642 times 10 to the minus 26 for this example. And then we use our kinetic energy to go a half mv squared. So we've got a half times our mass times our velocity. And don't forget that you must square that number on your calculator. So why don't you have a go, pause the video and type that into your calculator, see if you can find the answer. And if you've typed that into your calculator correctly, you should get 1.058 times 10 to the minus 16. So that's how you'd calculate the kinetic energy. Could we then look at how you would rearrange that equation to calculate velocity? So how would we calculate velocity? So if kinetic energy is a half mv squared, we could rearrange this and say that if we multiply both sides by 2, we get 2 times kinetic energy is mv squared. So then we could divide each side by the mass of the ion. So 2 times kinetic energy divided by mass is v squared. So velocity is the square root of 2 times the kinetic energy divided by the mass. So we know what numbers we'll need to put in. Now we need to gather that information. Do we have that information? So one of the things we need to look at is what have we got in the question. And we have the kinetic energy and we have the isotopic mass. So our first job is to find that mass in kilograms, because remember we can't put the isotopic mass in, so we're going to do 100 times 10 to the minus 3, and do you remember what we divide by? Divide by Avogadro's constant. Can you calculate the mass in kilograms? So I'm getting 1.661 times 10 to the minus 25. I'm going to put my numbers into my expression now. So 2 times the kinetic energy from the question, which was 5.77 times 10 to the minus 16, divided by my mass, 1.661 times 10 to the minus 25, all square rooted. So you can do that on your calculator. So you would press the square root button. You could use the fraction button within inside that and press 2 times 5.77 times 10 to the minus 16 and divide it by the mass that you've got, and you will get a a velocity, and I got 83363 meters per second. Now if I wanted to give that to less significant figures or even in standard form, I could do that. So I'm going to convert that. Could you do this? Convert that into standard form and 3 significant figures. So 3 significant figures, we put like a line here, 1, 2, 3. So it would make it 834, because the 6 rounds that up, 0, 0. And then if I put that into standard form, it would be 8.34. We've got 1, 2, 3, 4 times 10 to the 4 meters per second. So they're travelling quite fast, these ions. that's the end of that little section where we've calculated the kinetic energy or the velocity using the kinetic energy expression, and remembering we must convert our ions into kilograms.